This is an Xbox controller, and this is a fully homemade game controller with similar functionality for half the price. Let's make it. In this series, our goal is to make a fully functional game controller with Arduino that can compete with an Xbox controller. So first, let's take a look at all of the functions that are actually on an Xbox controller. We have 2 joysticks, a D-pad made up of 4 buttons, 4 face buttons, A, B, X, and Y, 3 control buttons, back, menu, and the logo button, and 2 triggers and 2 buttons on the top. The controller can also connect over a micro USB cable or Bluetooth. Now, to keep the price as low as possible, we're going to make a wired controller, which means we need an Arduino board that can connect to the computer as a human interface device, like a game controller or a keyboard or a mouse. Fortunately, the Arduino Micro Pro can do that, and it has 4 analog ports for the 2 joysticks and 14 digital ports, so we can have 14 buttons. Sorry, logo button, but how are we going to bring this all together? Well, we're going to design a custom PCB that all of the components can slot into perfectly. And also, you're going to need a free software called KiCad to make the design in. So follow the link in the description or go to kicad.org to download and install that. So the first thing we're going to do is we're going to go ahead and create a new project from File, New Project. And then we can just save this as a new Arduino controller project. And then we'll just open up the schematic editor for that project. So the first thing we need to do is we need to create a spot for the Arduino Pro Micro to actually be connected to the PCB in the schematic. So if we hit A to add in something, what we're going to want to add is a connector row. So this is basically like a row of pin headers. Here we can see a pinout of the Arduino Pro Micro, and basically that totals up to 12 per side. So we're going to look for the connection 1 by 12 pin, and we're going to go ahead and add one of these in. Now this is just one side of it, so then we'll go ahead and duplicate that with Command D, rotate it around so it's the opposite rotation. So this right here basically just represents where the board will slot into. So the next step is to label each of these ports here so that we can see what it is, and for that we can use the label feature in KiCad, which allows you to sort of teleport one end of a wire to another location. So if we press W to switch over to the wire tool, then we can just go ahead and drag out some little wires here and double click to end them in open space. And then we can use L to open up the label tool, and then we'll just label this D0. Then click again. For this one, it was D1. Okay, so this is our Arduino Pro Micro, and that's effectively where we'll slot it in. So the next step is to go ahead and add in all of the other components. So there's going to be 2 joysticks, the 10 buttons on the face, and then the 2 buttons on the top as we discussed. So let's go ahead and get one of the buttons set up, because once we do the wiring for one button, all of the other buttons are going to be basically the same. But before we do that, let's talk about how we're going to get this PCB manufactured. We're going to be using PCBWay, who are very kindly sponsoring these videos. They have a super awesome PCB service where you can upload your manufacturing files, change the PCB to a fun color, like red, and have it made and delivered to you very quickly. Check out the link in the description to pick up one of these boards right from PCBWay. So the first step is A to add, and then let's search for switch push. That looks promising. Yeah, so here we go. We have one with 2 leads, and then we have the dual one, which is one with 4 leads. So we can go ahead and grab this dual one, which is with 4 leads. If we go ahead and add that is our switch. So then what we're going to do is we want to add, if we add some wires here, we want to add a wire connecting these 2 pins, and then another one going out like this, and then we'll be able to add a label here. If we press L, we can add a label, and let's just say this is on D0. And add it there. So now this D0 pin is connected to here. And once we switch this over to the PCB editor, we'll have to manually route a track to go here. But for now, we just get that nice magical portal effect where the electricity will teleport from the end of this to this. For the other side, we just want it to be connected to ground. So we can add a wire here, click here to end it, extend it outward, double click to end it in open space, and then label, ground, and then add it. So basically what we'll do in the program is we will use digital write to turn D0 to high so that it's on, and then whenever this is pushed down, the electricity from the microcontroller will go out that way onto the ground line, so the pin will read as being off. So we want to keep in mind for deciding where D0 goes and where D1 goes and all these other ports go, where the other components are going to be physically on the board, because we are going to have to actually route the tracks to get to them. So let's say this, if this is going to be our board right up at the top center of the controller, then we can say that this could be our back button, which is right here to the left of the center a little bit. So it would make sense for this to be connected to maybe D2. So we can edit this and say, okay, this is going to be connected to D2. So then a wire could go down here to this switch, and then these ones can go up to like the buttons that are on the top here, and these other ones could go over to the joystick here and the D-pad down here, which is made up of 4 buttons. But we can rename this one here. So we want to leave this SW2 as what it is, because that's the actual like designation on the PCB for assembly or whatever. But this lower part that says SW push dual, we can change that to be a reasonable name. So in this case, since this is supposed to be the back button, we can just name it back button. Yeah, then the next thing is, since we do have the buttons up here on the top here, so let's go ahead and add those. All right, so then if we just duplicate this with Command or Control D, then we can move it up here and have this be either the left button or the left trigger, and we can actually duplicate it again to make the other one. And then we'll just edit one of these to be left button, edit the other one to be the left trigger. So then if we imagine these wires coming over here, we could have D1 go down and come up here, and then D0 could go over the top and go down there. So this could be labeled D1, and this could be labeled D0. And now we can make the D-pad down here, which is just 4 buttons. So if we duplicate that, we can put one here, one here, one here, and one down here. So we have some more. We already used D0, D1, and D2. So D3, we have to keep in mind, we don't want to connect D3 to this the up arrow on the D-pad here, because then how would we get to, well, we actually could probably go under and go there, but it might be easier if we make this one be D3, then D3 can come up and over and go down here, and then D4 can go under that and go right here. Then same thing, we probably want D5 to come down in here, so we can have that be D5, and then D6 can just come down here, and this can be D6. And that way we have D7, D8, and D9, which can go over to this section for the other buttons that are going to be over there. All right, now this is not very centered, so let's go ahead and move it over a little bit so we claim back a little more space. Then, since we want an arrangement with 4 buttons over here to be like the X, A, Y, and B, or for PlayStation people, circle, square, triangle, etc., we can just duplicate these and bring them up here. And okay, we actually also missed renaming them down here, so if we edit that, then we can make this up. This one can be right, this one is down, and this one is left. Okay, so now that we have those, then we can rename these using the Xbox convention. So this is A, this is B, this is X, and this will be Y. Okay, the other thing to consider is we're going to copy these two, duplicate them with Command or Control D, and then drag them over here. And then we will also need to duplicate this one so we can have another menu button. Duplicate that and put it right here. So that's all of our buttons. Now we can more easily consider which wires should go where. Say we connected D7 and D8 come out this side and go up and over. That'll be D7, and then D8 right below that goes up and over to right below that one and comes down here. So we could then put D9, have it come over under those two, and then come down right here, which could be really nice as well. And then all of these wires can still go out the bottom under D9, and there's no conflicts there. Our only issue is that these want to come across, and these also want to go down. But if we switch the analog ports to going here and then coming out, they should be fine. They can just go this side and come down. D15 goes down below this one, comes over. D15. D14 goes down, comes over, goes down to this one. That's D14. D16 can just go straight across and down to right where this one is. And then D10 can just go right below that down to here. Okay, so now we have all of our buttons connected up. Then we want to add, search for joystick, and we don't see anything. And the reason for that is because it is under potentiometer dual. We can just use this dual potentiometer because that's what a joystick is, just 2 potentiometers. And I'm going to name this left stick, and then we can just connect these to their appropriate ports. So we're going to need one side to be VCC and one side to be ground, and the same here. And then the middle on each of these will need to go to one of the analog ports. So A3 and A2 are higher up, so we're probably going to want them for this. So if we press W to add a little wire out, extend to the left just to make it a little nicer, and then add a label. Let's have this be A3, and we'll figure out how to connect it when we get to the PCB part, and then wire up, wire over a little bit, double click to end it. L for a label, that one will be A2. And then we just need to connect ground and power to both of these. So I'm just gonna add a wire. You can click to add a sort of corner so we can get around this label and not overlap with it. And then I can click again to create another corner, and we can add a label, ground, add it there, wire here. You can just go over and make that be ground with a label called GND. And then we just need to add a VCC on each of these. So if I copy that over, rename it to VCC, and then I can add a wire here. And then we can add another wire here, click to make a corner, and then VCC. So now on each of our potentiometers of our joystick, we have a VCC on one side, a ground on the other, and in between, for actually reading the value of them, we have A3 and A2 for up here. We can copy this and drag it down here, and this will be our right stick, which we will change this to A1 and A0. And now that is all of the input components, the 2 joysticks, the 10 face buttons, and the 2 top buttons on each side, so 14 buttons in all. Then if we want to add a little status LED, we can add an LED by add and searching for LED. We can go ahead and add one in, and then so that we don't fry it by sending 5 volts through it, we're going to want to add a resistor as well. So we can add, by pressing A, search for R, because the resistors are just called R, and bring that in. We can press R to rotate it, so it's rotated nicely, and then we can go ahead and wire it on this side to this. And then from this, we'll need it to go to ground. And then, so from this, that will be a VCC. So whenever the board is plugged in, it'll be sending out 5 volts on the VCC, which will go through this resistor, through this LED, and to ground. So we'll always have that LED on whenever the Arduino is on. Now that we have our schematic, the next step is to turn it into a PCB. So hopefully we haven't made any errors, but obviously we want to check by going up here and clicking this little rules one to perform an electrical rules check and seeing what happens. And you can see we have 2 labels that aren't connected to anything. Now, this is intentional. It's because we don't have anything to connect to these 2. We don't need to connect anything to reset. Unless if you wanted to add a reset button, you could just do the same thing as this, but with reset on this side. But in our case, we don't want them to be connected to anything. So we can say we don't want them to be connected to anything by hovering over that and pressing Q to add a no connect flag. And I added one there, and then it will just give me another one, which I can drag down here. And that just says that we're not planning on doing anything with those ports, so they should be ignored. Yeah, with them being ignored, we pass the rules check, so we can switch over to the PCB design workspace and work that out. However, before we switch over, we need to actually tell KiCad which physical component we're using for each of these schematic components, which is called the footprint for each of those components. So if we go ahead and use the mass footprint editor, which is this one right here, the footprint assignment tool, then we can go through each of our components and select what we'd like to use for this. So if you remember, this connection 01 by 12, these 2 are the pin headers that we'll be using to connect our Arduino. So all we have to do is go into the connector. There's a whole connector section here with all kinds of different connectors. We are looking for pin header 2.54 millimeter because that's the standard that the Arduino boards use. So we want the 1 by 12. It doesn't really matter which of these options we select, horizontal, vertical, whatever, because we're not going to be using any pin headers. From this, we're just going to be using the ones from the Arduino Micro and just slotting it in place. So we can pick any of these where it says the 1 by 12 and then double click to assign it. We could also select both of these to assign them both at once. Okay, now I accidentally assigned resistor 1 to that. So we obviously don't want resistor 1 to be that. For resistor 1, we want to go down to the resistor section, R, and look for resistor. So here we go. We want THD because that's the kind of components where they have the long leads and those poke through, and then we can solder them. Okay, so for this one, I think we want this axial DIN 0207, 6.3 millimeters by 2.5 millimeters by 10.16 millimeters horizontal. We can right click and click view selected footprint to see if it looks reasonable, and this does. We can also press option 3 to view it in 3D, and we can see, yep, that looks like the kind of resistor that we're going for. So this doesn't necessarily give you a good idea of size, but it does give you an idea of what the component looks like, so you can make sure it's not something completely different than the component that you actually have in mind. Okay, so then next is this LED up here, D1 for diode 1, and if we look for the LED section, LED THT once again, we're going to be looking for a 5mm LED, and we are going to, we don't want anything RGB because that's going to have like 4 leads instead of 2, so 5mm. If we go over the LED 5mm, we can see, yep, that looks reasonable, and if we go into 3D view, we can see, yep, that's the correct LED, that's what we're looking for, and it's 5mm, so we know it's the right size. Okay, so then the next thing is we need to do the joysticks. However, KiCad doesn't actually have a built-in footprint for these joysticks, so what we're going to need to do is we're going to need to find a link in the description so you guys can download it from there. Once you download it, you still have to import it. So I believe I still have it sitting around in my downloads folder, which we should be able to check. Yep, here I have, I copied it just into the main folder right here. It's called all caps joystick.kicad_mod. These KiCad mod files can be imported by KiCad and used as footprints. So all we have to do is you go to File, Add Library, and then you choose whether you want this to just be for your project or for all of your projects. Sure, maybe I'll use the joystick in other contexts. So I would say all, and then click on Downloads, and then click on Open. And now it knows that Downloads is the location where it can look for KiCad mod files like this joystick footprint. So if we double click on joystick to open it, then we can see this is the footprint for our joystick. And it's a joystick with a button, so you can see there's 4 mounting holes that are just for securing the casing on. And then there's like a little button up here, and there's a potentiometer here and a potentiometer here. So all we have to do is if we close out of this footprint editor, then now that we've imported that, if we go back to our footprint editor, we can shift select to select both of them. Then we want to go to our library, which is called downloads, because we included the downloads folder as one of our libraries. You could also move this joystick file to somewhere else, more convenient, and then list that as a library in KiCad. But for now we have it there, so we've added downloads joystick to both of these, and then we just need to assign right trigger, right button, left trigger, and left button. All of those will need to be a different type of button, an angled button that's angled at 90 degrees so that we can press them in a different way. So let's go ahead and get that. Left trigger, right button, and a left button. And we want to go to the button switch THT. Here is the angled one. This is tactile SKHH_angled, and this is exactly what the footprint of one of those angled switches look like. So we double click that to assign it. Now we just need to find the regular button, which we'll use for the rest of them. This one I believe is the correct one here, and there are multiple correct ones. Sometimes all that's different is these 4 pins are in the same place, and all that's different is a little outline around it. If we save that, I think we have added footprints for everything. So we can go over to the PCB editor, and we can go ahead and add all of our components to that. So we can press this button to update PCB with changes made to schematic, and then click update PCB. And boom, all of our components are plopped in for us. Now, what we want to do is arrange them. So if we hover over one of these, we press M, we can move it. M to move this one. This is the right stick, so it's going to go somewhere down here. Then we want to move each of these buttons to a reasonable location. So the left button be here on the left trigger, we'll just move it a little bit off of that. The right trigger here. Right button here. Now once we add in a sort of outline for the shape of the PCB so it can be shaped like a controller, then we'll be able to place these a little bit more accurately. Right now we just want to generally put them in a good position. Okay, so here's our PCB that we've developed so far, and what we were doing is importing the actual shape of the board. We can go to File, Import Graphics, or just press Command Shift F or Control Shift F, and then what we want to do is change the import scale. It's already here to 0.0215, and I'll include this file in the description. We can select the file, and then when we import it, it'll bring in the imported shape. For now, let's just tighten everything up around them. Back button and mini button, just right on each side. Left button and right button. Okay, so for these, on a standard controller, they're right over top of each other. The left button and trigger are right over top of each other. For our controller, just to make it a little bit easier, we are going to have them next to each other. Okay, so then we'll do the same thing here, lining them up, staggering them, putting them basically right on the edge. This one will even stick off the edge a tiny bit. First, though, let's bring in these. I think we want to rotate these so they fit more, and we can go ahead and move the resistor and LED in. So the next step is to route the tracks for the PCBs. So basically, you can see these little blue lines. That's where it's suggesting, oh, the nearest ground port should be connected to this. First, let's do the connections with the digital ports and the VCC ports. We can ignore the ground ports because we're going to use a trick for that to deal with all of the ground stuff at once. So what we do is we go over to here to where there's track selector tool, route tracks. You can also press X for that. And then if we click on a port, X to use the tracks tool, and if we're hovering over one, it'll go ahead and start the tracks tool. And it's the same as kind of those wires earlier. It'll just auto make a path for you. So you can see we can just auto drag across there. If you zoom in, you can see what the ports are. We don't need to worry about the ground ports. You have to worry about all of the digital ports. Okay, so here, I'd like it to go around like this. So instead, like it might do all kinds of weird things like this. So if I go straight out, I can click to set a corner, and then it'll try to use that corner. So now here's an instance where I want to use some of the corners because I don't want it to be super weird. This is fine. But I want it to go around these D4 ones so that we can still access them later when we're connecting the D4 wire in just a second here. So if I had done the path that was suggesting there was like through here, I wouldn't be able to access D4. So that's just when you want to keep an eye on. Okay, now everything on this side looks great, except that we don't have this joystick connected up yet, which is where things get fun. Okay, now we do actually have paths through here. If we can get a VCC over here for these two, A2 and A3. So let's see. Ooh, VCC is above A2 and A3. That's actually so perfect. We want A2 to be the one down here, so we can draw a line to A2, like maybe like this, and then we could do A3 over it to right here. So let's go ahead and fix that in the schematic. Go over this, edit this, and then we can change this to A2, and we can change this to A3, and just like that, all of the problems in the PCB have been solved. A2. Now we can go. Perfect. That's A2. Then A3 just goes over like that, and VCC goes through this hole, and it's, yeah, that's actually just so perfect. Try to keep them tracked from being too short, just too short segments, because that just concerns me. Yeah, that actually worked out super well. Everything on this side is connected now, so now we just have to do this side. Everything is connected except for the ground wires, so what we're doing here is, in this case for the board, there's actually 2 layers of copper. So instead of there just being other stuff on the bottom side of this copper, there's actually the core of the board, then another layer of copper, then another layer of cover for the copper, and then another layer of decoration on that. So there's a top and a bottom of the board, and each of them sort of have their own copper layer and cover layer and decoration layer. All of these red lines that we've just drawn to connect everything up are on the top layer of the board. And then on the bottom layer of the board, we can have all of the ground connections. So the way we do that is we draw out a plane of entirely ground, and we put that on the bottom layer. So we place add filled zone, and then we just say which layer it's on. So we want this to be on the back layer, which is b.cu, and then we want to set this to the ground so that this is connected to the ground ports on the Arduino, and that's it. Then we can start drawing it out. Now that we've set that up, that dialog just pops up as soon as you click down the first point. You can see it's already showing us a little blue thing. So we just want to make sure all of the things are in, and there we go. Now that whole area is going to be copper. Now we have to tell it to actually fill that. Edit fill all zones, which is apparently B, and there you go. That's the back copper layer. So the front copper layer is all these little wire things, and the back copper layer is just that little shape, and it's connected to the ground pins. So if we look in closely here, we can see these lines, which show us that those ground pins are connected to it, and also every other ground pin. Let's go ahead and view it in 3D with option 3, and that looks good. You could basically just send this off to manufacturing. So how you would do that is go to fabrication outputs and Gerbers. So the Gerber file is the main file for manufacturing this board. So you change the directory to wherever you want it to actually output, and then you click plot, and then you click generate drill files. I don't think the order matters, but you got to do all these steps. You plot it, generate drill files. You want to make sure these settings are correct, and then generate drill file, generate map file, and that's it. Now you have the Gerber file, the drill file, and the map file. And now we have our completed PCB design exported and ready to go. Let's go ahead and buy our PCB and assemble all of the components onto it. So the first thing we're going to do is we're going to actually order the controller PCB from PCBWay.com. Then we can click the quote now button and quick order PCB. And then we can add a Gerber file. And this is just all of the files that I showed you how to output in the last video, which I have right here, zipped up. And then we can just click plus add Gerber file, select that, and hit upload. And you can see that right away it's already giving us a quote for how much this is going to cost. And if you want to change the color, you can do that, and you can click specify specify a location, and then if you simply add a text field on the board where it says way, then it'll put the product number right there. So for me, I put it under where the Arduino Micro will go, so it's hidden away. Now that we've got our PCB and all of our components, let's go ahead and assemble our controller. The first thing we need to do is prepare a couple of the components which aren't quite ready to be soldered to our controller. So for the joysticks, since they're already soldered onto a PCB, we need to desolder them from that PCB so that we can connect them to our PCB. So what I'm going to do is desolder the joystick in parts. So the first thing I'm going to do is I'm going to pry back the two potentiometers, and then we can desolder those two separately. I'm also going to cut the 4 pins that go into the board so that we can simply remove the entire assembly. Once we desolder the button and both potentiometers, then we can snap the potentiometers back on and slide it into our PCB so it's ready for soldering. The next thing we need to do is go ahead and assemble our Arduino micro board with its header pins. This is much easier. All you do is slide the header pins into the holes, clip both in place with your helping hands, and then solder down the line. Now that we've got our Arduino micro assembled and our joysticks removed from their boards, let's go ahead and add all of our components to our PCB. So we have the Arduino Micro, the 2 joysticks. We also have the 4 buttons that go on the top, and instead of inserting them all so that they're on the top side of the board, I decided to put the outer ones on the bottom side of the board so that I can have my pointer fingers on the top ones and my second finger on the lower ones. I may also switch which one is the button and which one is the trigger on each side, but that's a programming issue. We can also add the resistor and bend its legs out so it stays in place, and the LED doing the same thing. And then we can just go around and insert each of the buttons into their appropriate holes. Now to do this, we just want to bend the button pins in together a little bit more, and once you've done a couple, you kind of get a knack for this, but we want the spacing of the ends of the pins to be the same as the spacing of the holes on the board so that we can slide it in. Now that we've added all of our components, we can flip the board upside down and solder each of the pins in turn. Once we've finished that, there's the 2 buttons I put on the bottom, so we'll need to switch over to the top side and add some solder there. And now we have our finished controller with the Arduino micro board, 10 buttons on the face, 4 buttons sticking off the top, 2 joysticks, and an LED and resistor. Now that we have our finished controller, let's go ahead and program it so that we can use it to play games on our computer. So if you follow this link in the description, you'll find this page, the Arduino X Input AVR library, and we can go ahead and copy this link right here. And if we go over to our Arduino IDE, we can go to Arduino IDE, Settings, and then click this button here, which will open up a list of additional boards manager URLs. And if we add a new line and paste this in, then it'll tell the Arduino IDE where it can find the information to communicate with this board in a slightly different way. So then if we go over to the boards manager, which is the second from the top option, we can search for X Input, and we'll see X Input AVR boards, which we want to install. The next thing we need is another library, this time a standard program library that will tell our Arduino how to act like it's a controller. So this is the Arduino X Input library, not the AVR boards library, and we'll just download this using the code download zip button the same way we would normally, and then we can go to Sketch, Include Library, add.zip library, and select the library we just downloaded. Once that's installed, we can add a couple of lines at the very top of our sketch and type #include xinput.h. And now we're including all of that code so that our Arduino can act like a controller. The next step is in our setup function, we want to go ahead and set up the controller functionality. So the first thing we need to do is say xinput.setAutoSend false. And basically we're saying that we would not like the library to automatically send commands when we press a button. We want to manually send the commands over, and that way we can register multiple button presses at the same time, which is important to reduce latency. Then we want to do xinput.begin to go ahead and start up the back and forth between the computer and the Arduino controller. Now, if you recall, when we set up the controller's PCB, we made each button connected to a digital port on one side and ground on the other. So when we press the button, it will be connected to ground and we'll register that on the Arduino. And that means that by default, all of the pins need to be pulled up, which is a fancy way of saying they need to be connected to the 5-volt pin on the Arduino through a resistor so that all of them register as on by default, and only when they're pressed do they register as off. So what we're going to do is we're going to say pin mode 0, input pull up. and we're telling the Arduino, hey, we want you to make sure 0, one of the digital pins, is always on, except when the button is pressed, it'll actually be off, and that'll be something we can notice and register. Then we're just going to do the same exact thing for all of the other digital pins. So pins 1 through 10, 14, 15, and 16. So I've gone ahead and copied in a list of all of the buttons' names and then what port they're on. So for example, the left trigger is on port 0 and the left button is on port 1. And what we can do is after each of these lines, we're going to start with all of the standard buttons. For the left button, we can say x input dot set button, and then the button is button underscore LB, and then we'll say digital read on port 1. So now we're telling the X input library, which will in turn tell the computer, that the button LB is either pressed or not pressed depending on what reading we're getting from port 1. Now we want to flip this around so that it's the opposite reading, because remember, when our buttons are down, they're off, and when our buttons are up, they're on. So we can put an exclamation point in front of that, which is saying not whatever the digital read on that port is. So if it's a 1, it'll instead be passing a 0 to the left button. And then we can do the same thing for the other standard buttons. So the back button, the right button, the B button, the A button, the Y button, the menu button, and the X button. And the only thing we need to change here is that the menu button is called the start button. So the name for it is button underscore start. Now on a normal controller, all the buttons are expected to be a 0 or 1 value. However, the triggers are expected to be a value from 0 to 255. But we don't have analog triggers, we just have digital triggers. So to fix that, we're just going to say x input dot set trigger, and for this top one, it's the trigger underscore left. And we're going to set it to the digital read port 0, since this is port 0, multiplied by 255. So now, if it would be 0, it's still going to be 0, and if it would be 1, it's all the way up to 255. Now remember, we also need to invert this, so I'm going to change this to negative 255, so now it's going to be minus 255 for pressed and 0 for unpressed, and then add 255. So if we walk through this, if it's a 0, it'll be 0 times anything is still 0, plus 255 is fully on. And if it's a 1, it'll be 1 times negative 255 is minus 255, add 255, it'll be 0. So now we've successfully inverted that, and we can do the exact same thing for the right trigger with trigger underscore right and digital read on port 7. Now the D-pad is still expecting standard digital input, but we can set the full D-pad at once by running x input dot set D-pad. And then for the first one, we'll do not digital read on port 3, then not digital read on port 5 for down, not digital read on port 4 for left, and lastly, not digital read on port 6 for right. And the last thing we need to do is set up the joysticks. So the joysticks are expecting a value from minus 32,768 to positive 32,767. But the joysticks that we're using only give us a value from 0 to 1,024. So back up in the setup function, before we run xinput.begin, we'll run xinput.set joystick range to 0 to 1023, so it'll automatically remap those values. Then in the loop function, we can simply run for the left joystick, xinput.setJoystick, all caps joy underscore left, comma, analog read on port A3, and then analog read on port A2. And of course, we can do the same thing for the right joystick, simply changing it to joy underscore right, A1 and A0. And at the very bottom, we can simply run xinput.send to send all of the input that we're calculating in this section here over to the computer. And now we can go up to Tools and change the board to X input AVR boards, Arduino micro with X input, and then we can go ahead and upload our code. And with our controller connected, we're able to see that all of the buttons and joysticks are working correctly. Now that your controller is finished, check out this video right here to build another awesome project.